Let's set off with our work and start with cutting along the material. Some slightly wider planks as I have no more narrow ones. I'll only need one plank because it will be glued to the thickness of 100 mm. So 250s will be fair enough. See how the chips fly. It's not possible for the exhaust to catch everything. Cutting across, and here, I have to admit, lazy me hasn't changed the disc. The cut does not need to be very clean. It just has to be done. Folding down the T-square out of the way. It goes under the table. Cutting more than 800 mm crosswise is so much fun, huh? I also omit some defects. Since so wide planks will certainly contain some discoloration which I'd like to avoid. Skipping to the edging machine. Traditionally we are starting from the wider part, then upright. You know, for so many months of work, I haven't changed blades yet. Recently I have been surprised to realize to work on these too long, but with no defects seen on the material. So I carry on. Can you see the box under the wall? I still haven't opened it. Smiley face. I'm testing my patience. I check the thickness here. 44.5 millimeters. That's exactly what I needed. This was close, wasn't it? Here we are getting to the things that are made according to Lake Erie, or the manufacturer of these clamps. The first two lines are to be tangent to the thread. Another, third line is the middle line. So we need to split it into two. With dividers you can be most accurate. The last line that we need to make is 3 inches to the left from the middle. I use the inch ruler here to avoid conversions. The left line will be the cutting line. For now I don't touch it, I'll leave it as an offcut. Next activity is fully driving the thread in and driving out by 1/4 turn. Then we measure how much the screws stick outside. Here it was about 228 or 226 millimeters, and such line I have made quickly. After gluing together those two planks that you saw before, they were too thick. I decided not to tire out the circular saw, since for a single cut it can be done by a bandsaw. This goes fast. I had a wide band on, so chop chop and it's ready. Later on, this thick element will have to be brought through thicknesser to even it out. So I always cut with a bigger reserve. One-two passes and the element is ready. This element I have here will be the front of the joiner's bench. Thinner than the middle one, which will include space for clamps. The cutout which I will now prepare is for the bolt, which you can see here. At this spot there will be an extensive cutout. I'm using marker. Transferring the dimension. The marker is of course tightened up. To transfer to the table. This cutout here. The crucial spot. It must be made very accurately. On the table you can see the flap with 5 holes. It was 0.5 inch. For 12.7 millimeters, and it must be done exactly to this depth. First I have set the depth. Checked whether it is accurate, and after adjustment I could cut out deeply and widely. A wide end mill, spiral, gives an extremely clean milling. A couple of passes, but not to the very end. I'll explain in a minute why not to the line itself. Exactly the same activity must be performed on a joiner's bench element, so. Marker again and transferring exactly the same dimension from that external element of the bench for the countertop of the bench. I use the pencil for you to see the line. And the fat again, or the table I work at, is perfect for this job as I can lower it. I put the countertop of the joiner's bench upright and start to mill. So, the depth of the mill stays the same. I only changed its position. You can see how much chip dust is generated. There is no good way to collect it, since even protective caps for a miller cannot be placed here because the mill is into the depth of the material. I think that there were about 5 passes and it's ready. Why haven't I reached up to this line before? It is very important here to make both cuts at the same depth. The last pass on this element, and I'll try to get exactly into the line. Cut it out, and with this setting I'll skip to the front element of the bench. The table goes up and we skip to the element which is waiting, just to make the last pass. We have 2 elements made 100% the same. The cut is of the same width. I've checked if everything is okay. There shouldn't be any errors here. It's exactly 12.7 deep. Any error? The 2 elements are facing and the slide will move. This needs to be worked manually. I wouldn't use the miller here. A couple of moments of mortising to get a straight line. Theoretically, the place that I clean now could be deepened or extended more to the left. And then it would be hidden under this middle element of the joiner's bench. where the holes for clamps are. But if it's to be nice looking, I'm doing my best. Here, I think that wide chisels are of advantage. You can base for a wall on what has already been mortised, and a part of the edge can be moved to the spot that has not been cut yet. Then it can be done very well. Another option at making knife cuts, giving space for the chisel edges. Now cutting these slips that should be 3 mm shorter than this cut that I have made. All the dimensions that I don't mention here in them should be measured and put onto the table. By which you check and cut further elements. A little burn, isn't it? The cut is super clean. Now I'm marking the spot for the holes that must be made under the big screws/bolts. They are more than 6 mm. They were included in the kit from Lake Erie. There's a straight line from the bench bottom edge, and now it was enough to mark with the penciled spots for the bolts. And we have perfect alignment for the seats and the slip. I realize this film will be long, but I think it will guide you by the hand. A sharp boring bit and we're rolling. I don't need to worry about limiting the depth. There will be no conflicts. Although the first bolt on the right can collide with the large screw that tightens the external element. I'll look at it later. I'm checking if everything matches. I'll use these 2 slides so that they make a distance. All the 3 elements are tightened. Not too much. Now bolts/screws. They are very strong, between 6 to 7 mm. Aggressive thread. Heads for keys. I was lucky to have a case with inch attachments. So everything matches. I tighten it roughly. Then slight adjustment with a ratchet spanner, so that it's not tightened too much. The manufacturer suggested inserting a paper sheet of Ca 0.15 millimeters. You insert the paper, tighten up and pull it out, leaving the distance of ca. 0.2 millimeters. I had to cut another set of bolts. Because the thickness of the element which will be the front of the bench dictates the depth and hence the length of the bolts. If I don't do this, then tightening another element would drive it through. I didn't have so thick screws of this length. Now the depth limiter. I don't want to go through. As in the previous element, I tighten the slip, press it all together and tighten with bolts. This beach slip. Its dimensions. Holes, it's the top world class. I don't know what CNC they use, but the workmanship is perfect here. It is so polished and made. That it's been a long time I have held such quality in my hands. All put together, and now this thick element which you can see. This middle element, in which I have to mark and prepare holes for installation of the clamps. I was thinking, how close they should be. It's a small joiner's bench. Very special one. For work of various kind. But not for large elements. I decided to make 4 holes. I'm marking middle line with the most accurate ruler I have. I wanted to have this line visible, but without making cuts and then the dividers again. To transfer the holes in the same distance. How do I make such deep holes? I was wondering, and my first thought was a pedestal drill. But my drill is aged and also runs out. I turn it on and look at the bit. Did you see it move at all? I think that the drill lathe is an underestimated tool in a workshop. Maybe it's subjective. But I think I should use it more often. There is virtually no run out on the spindle. Look at the quality of the holes made. Subtitles created by Amara.org community.